welcome to section 8.2. So we're going to learn about component form, and you use the X, Y, that's the horizontal movement, that's the vertical movement, just like when you're finding points. A unit vector is 1 unit long, and we will talk about linear combination. Let's get past some of these review questions. So component form, you notice that they use these fancy vector brackets instead of parentheses when they talk about this. So if you do this, you mean a point. If you do that, you mean a vector. And that's considered component form. The magnitude is the length of how long something is. And we know that a unit vector is 1 unit long by its name. And if I have a 1, 0 vector, we would consider that an I vector because it's 1 unit in the X direction. And we have this unit vector going vertically. We consider that J. So there are multiple ways to write vectors: the standard unit vector method and component form so far. When we use this unit vector, that's the IJ form. Standard unit vector is IJ form. A unit vector in the same direction. For instance, if we started with this vector that I started up on top with, 3, 2. If I want to find the magnitude, sometimes use, like if this is vector V, the magnitude, we could write that as, with those absolute value symbols around it, that's the symbols for magnitude. And to find that, we simply use the square root of 3 squared plus 2 squared. So I get the magnitude of this is square root of 13. So if I want to find a unit vector in the same direction as my original 2, 3, we know that that is the square root of 13 long, so I need that to be 1. So I would divide that by its magnitude, and I would get 3 root 13 over 13, comma, 2 root 13 over 13. And that would be in the same direction as the original, but only 1 unit long. Did all that. Notice I started here with a couple points, and I want to find the vector, the length, and the component form of that vector. So what I'm going to do there is I'm going to count how far am I moving in the X direction, how far am I moving in the Y direction. That would give me the component form of that. I notice that I'm moving 3 in the positive X direction, going from 1 to 4, and I'm going up 4 in the Y direction. To find the magnitude of that, again, we would just do the square root of 3 squared plus 4 squared, which gives me 5. So that vector would be 5 units long. If I want to write that in as a standard unit vector, we would write that as 3i plus 4j. Just different methods of writing the same thing. And if I want to do the unit vector in the same direction, again, I just divided the whole world by the magnitude of it. And so I have 3/5 and 4/5. Now, notice that I have an angle here, my angle up. We can also find the direction of that vector by using the tangent of theta, that's this guy right there, is equal to the opposite over the adjacent. So the inverse tangent of 3 over 4 would give me that angle. Let me get that just to be sure here. Inverse tangent of 4 divided by 3 gives me 53 degrees. So this would be a 53 degrees angle from the horizontal. And that's just another slide of the same type of stuff, just rewriting it in component form, standard unit vector form. Oftentimes kids get those mixed up. Make sure you keep those vocabulary fresh in your head so you can do them. So let's talk about this vector, and we're going to do, looks like the whole thing here. So I know this is the x movement, this is the y movement, and so my component form is going to look like 2 in the x direction, 6 in the y direction, from -3 to +3. In standard unit vector form, that's the ij form. I'm going to go 2, not comma, 2i plus 6j. And my angle direction, so we're going to say this direction from the horizontal, and I'm going to say the inverse tangent of the opposite over the adjacent, and I think that is 71.6 degrees. And find the magnitude of this. I would go square root of 2 squared plus 6 squared, 36, and 4 makes 40, 2 root 10. And the last thing, if I'm going to make a unit vector in the same direction, I have to take my original vector and divide that by my magnitude, in which case I get root 10 over 10, comma, and 3 root 10 over 10. All right, operations with vectors. Well, we can do addition, we can do subtraction, we can do some scalar multiplication. Now, a scalar is not a vector. It's something that just, if I have a vector that's that long, and I want 3 times as long of a vector, that would be a scalar, k, that you multiply by. So scalar is just something that makes it longer, makes it shorter, because you can multiply by fractions too. So let's do some operations with these guys. I have the addition, you just add the x values and add the y values. Now subtraction is not really defined as such, but we can do that, which would mean the same as 3, -2, plus -5, -1. Notice we distribute that negative through and then do the addition. Kind of a picky thing, I guess. But, and -3. And notice these numbers in front here, those are scalars. And so if I take, we gotta see them here. So if I take 4 times u, I get 12, -8. And then I'm going to go plus, and I'm going to distribute that negative. So it's going to be a -10, -2. And then I add them together, I get a vector of 2, -10. And so find a component form of a vector with magnitude. So here we're starting out with a vector that is 12 long and the direction of 300 degrees. So I'm going to call that my vector. And what component form is the x value and y value. Here they're giving me just the length and the direction. So There's your 300 degrees. So what I'm going to do is I'm going to break it down into its x part and its y part. Okay? So, where is that? There it is, I think. So we know that I'm going to go 12. Let me see here. This is the adjacent side. This is the opposite side. And to find the x value, that's the adjacent, I'm going to do 12 cosine 300. And for the y value, I use the sine, using the opposite and hypotenuse. So I would go 12 sine of 300. And my vector simplifies down to 6, and sine at 300 is negative root 3 over 2 times 12 gives me negative 6 root 3. Or, I think if you're cranking on your calculator, you get that. So the way to find component form would be to do your magnitude of your vector times the cosine theta, magnitude of your vector times the sine of theta, is how we go about finding that. So if I want to find a unit vector, now I've talked about unit vector, that's a vector that is 1 unit long in the same direction as the original. So what I'm going to do is I'm going to find my magnitude, which happens to be 4 squared plus negative 3 squared, which gives me 5. And so I'm going to take my vector divided by my magnitude of my vector. And so there's my vector. Notice the vector symbol, I haven't talked about it, but it's only one arrow on top of it. It's like a line, but it's only got one direction on that arrow. And so my vector, 4 negative 3 divided by 5, gives me a unit vector of 4 fifths and negative 3 fifths. Okay. And we did that. And I don't think we need to do a unit vector, another one so soon. And I think we've done plenty of those. All right, let's get to this. It says write a component form of a vector with an initial point at negative 2, 1. And the terminal point, so the initial point is where it starts, the terminal point is where it ends at 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So here is my vector, one side. And so what we're going to do is we're going to find the component form. So my movement from point A to point B is up 7. My movement of the y value is down 6. And so there is my component form of that. This is a movement of 7 that direction and negative 6 that direction. If you're going down, down is a negative direction. And for finding magnitude, it doesn't really matter because all we're doing is squaring both of them. So negative or positive doesn't matter. 49, 36, 85. So my magnitude is 85. That's that. And my direction would be my angle. So the direction of my vector is going to be from the horizontal that direction. So, and we know that this angle going down is going to be, because it's parallel to, this side is parallel, this side would be the same as that angle in there. So I'm going to use my tangent. So the tangent of my theta is equal to the opposite or the adjacent. Inverse tan, and Let me grab that. Inverse tan